Welcome to our second lesson on sequences and series. Today we're going to be looking at series. My Siri on my phone thinks I'm talking about it. In any case, we're going to determine when an arithmetic series exists and evaluate its sum if possible. So series arise in many applications, and the mechanics of series also support the development of calculus in particular. Even though we won't go into the calculus nature of series and sequences in this course, it is still an important foundation for future math classes. So a series is the sum of all sequences in a, let me try that again. A series is the sum of all terms in a sequence. So if we take all of these numbers, add them together, that is the series. So a series is a number, not necessarily a list of numbers. So series also have special notation. This is called sigma notation. And it's called sigma notation because this is the Greek letter sigma. So we have along the bottom the index. Note the index may be any variable. Then we have the bound, sometimes called the upper bound because it's on the top. Occasionally we'll also call this the limit or the upper limit, depending on whom you ask. And then this is going to be an expression. In our context, this will be the general term of the sequence. The sequence whose terms we are adding to make the series. So note that the upper bound can equal infinity. It can also equal any other number, any other whole number, but on occasion we will let it equal infinity and see what happens. So if we want to evaluate some sums, we first need to identify, that reminds me, I didn't actually say how you read this, which is an incredibly important part. So the way you read this is the sum of I can't really do a subscript, I guess that was the best way. The sum of AI from I equals 1 to I equals n. So it's the sum of AI from I equals 1 to I equals n. So we're adding all of the terms and from this expression for the values from 1 to n. So now if we wanted to come here to read this, let me come to text. To read this, it would be the sum of 3n minus 1 from n equals 1 to n equals 5. And so what we're going to do to evaluate this is construct a table. So we have a column for n, and then a column for 3n minus 1. And so our n's are 1, 2, 3, 4, and 5. And then we need to plug these in. So we have 3 times 1, which is 3 minus 1, so that's 2. Then we have 3 times 2, so 6 minus 1 is 5. 3 times 3 is 9, minus 1 is 8. 4 times 3 is 12, minus 1 is 11. And 5 times 3 is 15, minus 1 is 14. And then we add all of these numbers together. So 2 plus 8 is 10, plus 5 is 15. 15 plus 11 is going to be 26. And then finally, 26 plus 14 is going to be 30, 40. So this sum is equal to 40. Here, we would do the same thing. So reading it, let me turn back to the text. We have the sum of 2i plus 1 from I equals 1 to I equals 7. So we're going to add up this expression for values of I from 1 to 7. So let's pick a new color. How about green? So we have I, and then 2i plus 1. So we have 1, 2, 3, 4, 5, 6, 7. So we have 1 times 2, 2 plus 1 is 3. So 4 plus 1 is 5. And notice that this is a linear equation, an arithmetic sequence. So we can find the remainder just by adding 2. So 9, 11, 13, 15. Now we have to add them up. So 3 and 5 is 8, plus 7 is going to be 15. Then 9 plus 15 is going to be 24, plus 11 is going to be 35. Now I'm going to actually add the 15 next, because that's going to give me a solid 50. And then when I add plus 13, we get 63. So this whole series, this whole expression is equal to 63. Now, once you have the table completed, you could more easily, or perhaps more efficiently, just plug it into your calculator and evaluate. So let's do one more example. And I'm going to mix this example up a bit, if it lets me. And it is not going to. All right, so rather than starting at 1, we could have an expression starting at 3. So we are going to just change that up a little bit to see how it impacts it. So this would be the sum of 2k plus 1 from k equals 3 to k equals 4. So even though we're starting at a different number, the process is going to be the same. Let me once again pick a new color. How about blue? So we have our values for k and our values for 2k plus 1. So our values for k are just going to be 3 and 4. So 3 times 2 is 6 plus 1 is 7. And 4 times 2 is 8 plus 1 is 9. And so when we add these together, we just get 16. So this whole series is just equal to 16 because we're starting at a slightly higher number than 1. So that's going to wrap it up for this video. In the next video, we're going to look at a formula for arithmetic sequences and series in particular.